Okay, a pure chemical compound can be. The question, a pure chemical compound can be. It should be a compound and that is also pure compound. Can be, they're asking us. Okay, a compound is a pure substance, we know. The options are only heterogeneous, only homogeneous, both heterogeneous and homogeneous, neither heterogeneous and nor homogeneous. What is the option now? Who will answer this? Is it option A or option B, C or D? How many of you are going with the option heterogeneous? What does the word heterogeneous mean? Did you ever see the word heterogeneous in compounds classification and compounds characteristics? No, right? So compound is always existing in homogeneous in nature. Okay, homogeneous in nature. So absolutely the answer will be only homogeneous. A pure substance which is under the compound. Compound is a pure substance and always exists in a homogeneous nature. Its nature is always homogeneous. So option is B, only homogeneous. Clear with that, children? Very good. Moving next. Okay, diagrammatic. C in the between, O, side by side, represents what? First, just see the question carefully. What is that question talking with us? Okay. O, C, O. There is something born in between and these three atoms are combined to get what? What is that? CO2. What do we call CO2 as children? Come on, tell me. Carbon. C stands for carbon. And how many oxygens are there here? 2, right? So what do we call 2 according to our chemistry? Di. Very good. Di. And we call oxygens in the format of combination as oxides. It's a carbon dioxide. What is that? Carbon. C stands for carbon, and O2 here stands for, one second, okay. Moving next. Okay, question number 10. Diagrammatic question, yes. So it is representing what? O, C and O. Can you use the question carefully, children? Okay, I'll do it for you. There is O, C and O. All together present in the bonds, O. And yeah, club with C and O. What is this particular structure called as? Can you differ the name? How many carbons are there actually? Come on, how many carbons? 1 carbon, okay. How many oxygens? Okay, why I wrote first C in the sense, the middle atom is there, no? This is the middle one. O and O side by side, and between we have an element C. That's the reason I'm writing it first. Okay, clear? So C first. After that, what do we get? O and O. How many oxygens are there, children? 2. Very good. CO2. You know what is the name for CO2? Come on, tell me what is the name for CO2? What do you call CO2 as? Very good. C stands for carbon. Okay, C stands for carbon. Very good. Then what is mean by O2 now? We know O2 is oxygen gas. Okay, but you should not write oxygen gas like that in the particular formula. It is having some different name. We'll see what is that. Here, first, leave the oxygen aside and write the name with the number. What is the number talking with us? 2 means? 2 means, in chemistry language, 2 means? Very good. Di. D-I, di. Very good. And what about the leftover one? Leftover one is, yeah, oxygen. But we have to write as oxide because it is a name written with carbon in the before. Okay. It is carbon dioxide. Why dioxide? Because there are 2 oxygen atoms in the particular formula. Okay. Accordingly, CO2 means carbon dioxide. Okay. Very good. So, in this particular structure, what do we call this structure as? Containing the formula CO2. What do we call that? What do you call the answer? Is it an element or a compound or a mixture or all of these? What is the answer, children? Is it element? No, because there are 3 elements altogether. Very good. So, can I say it is a mixture? No. Why? Why not mixture? Did you remember the mixture's classification and definition? Yeah, very good. So, coming to the option next one is compound. Is it a compound? Very good. Why it is a compound? Come on, the definition I needed. Compounds are a pure substance, very good, homogeneous in nature, very good. But they will, contain the proportions, fixed proportions by weight in a particular chemical formula. Did you remember that? Very good. In this particular CO2 formula, always we do have 1 carbon and 2 oxygens all over through. That's the reason fixed proportions and is also a compound. Option here is compound, but not all of these. Okay, it is not an element because it is having 3 atoms, carbon, 1 atom, and also other 2 oxygens are also there. No, that's the reason. Okay, element means it should contain only 1 element, but here we have 3 elements. So option A is not right and mixed is also not right. Coming to the option B, a compound is the right option here. Okay, moving next. Question number 11. Okay. The molecules of which of the following substances will contain the same kind of atoms? Okay, it should contains same kind of atoms, same kind of atoms. Coming to the options. Option A, oxygen. What is oxygen formula, children? Oxygen gas. Yes, O2. Water. Formula for water. Yeah, very good. H2O. Carbon dioxide. Just now we discussed, no? CO2, very good. Sulfur dioxide. Sulfur. How to read the formula? I told you, no? Sulfur. Symbol for sulfur? Yes, capital S. Okay. Now, dioxide. Oxide in the sense? O. Very good. And how many oxygens should be there here? Dimeans? Dimeans? 2. Very good. SO2. Okay. Now, tell me the question again. The molecules of which of the following substances, all these are molecules, yes, it is having more than 1 particular atoms, okay, will contain the same kind of atoms. Okay, here atoms in the sense, coming to the question, atoms here are 2 oxygen atoms, 2 hydrogens and 1 oxygen atom. Here 1 carbon atom and other 2 oxygen atoms. Here 1 sulfur and 2 other oxygen atoms. So particularly for the question, I written the symbols also, no? The formulas, chemical formulas. By this you can clearly say that option A is right answer. Why option A? Because it is containing same kind of atoms. What are same kind? The 2 are oxygen atoms. Hence you can say the option A is right. Okay. Good job. Clear with this? Good. Moving next. Question number 12. Okay. Which of the following non-metals is a good conductor of electricity? Which of the following non-metals is a good conductor of electricity? Children, we discussed the following metals, non-metals list one by one, right? So, in that metals, I gave you metals are good conductors of electricity. Did you remember that? Metals are good conductors of heat and electricity. Did you remember the point, children? Metals. Okay. Coming to non-metals, non-metals are bad conductors. Comparatively to metals, non-metals are bad conductors of heat and electricity. Yeah. Electricity and heat. Yeah. Okay. But in that we have an exception. In that case, we have an exception too. Okay, here the question here is they're asking us only non-metals. Non-metals. Which of the following non-metals is a good conductor of electricity? Okay, leave the metals aside. We're talking about non-metals. In the non-metals, all the bad conductors, na? How can we again define these options again? How can we do it the sum? Okay, in that particular concept of non-metals, we also discussed about the exceptions in the non-metals, where some particular things are good conductors of electricity. What is that name? Do you remember, children? The name is starting with G. I'm giving a hint, starting with G. Any idea? Come on. It is a graphite. It is a graphite. Now, accordingly, the options, let's see. We have options carbon, nitrogen, fluorine and oxygen. Graphite is not there, no madam. How can you write that answer? Come on, do it. Carbon is a, come on. Did you have any idea regarding graphite and carbon relationship? No. See, graphite is something made up of carbon, children. Okay. That's hence they gave the indirect answer for us to think over. Okay. This hence, level 2, we entered level 2 now. That's the reason we should think ahead. Okay. So, graphite is a, substance made up of carbon. That's the reason the option here is carbon. Now, did you understand why it is carbon? In the exceptions column, I didn't give you any carbon name. I just simply gave a graphite. Graphite is a good conductor of heat and electricity, the exception of in the non-metals. Okay, all non-metals are bad conductors except graphite I gave you. But accordingly, let's see the options. There is no graphite. We have to look carefully into it. So, carbon is given for us. So, carbon is the right option, right matching for this graphite because graphite is made up of carbon. Very good. So, here ends the option is A. And moving next to the question number 13th. Select the metalloid group from the following. Come on, very quick. Answer be quick. What is the option? We have here helium, neon, argon. What are all these three? Helium, neon, argon are metalloids are. Come on. Helium, neon, argon are what gases? Tell me what gases? Noble gases or rare gases or aerogens or inert gases. So, all this belongs to gases. Fine, leave it aside. What about this SN, BA and PT? What does SN stands for? SN stands for tin. Okay. BA stands for barium. PT stands for platinum. Can you see all these three belongs to metalloid category? No way. These three belongs to metals. Okay. These three are metals. The first option is noble gases. Okay. Coming with option B. What is that? Germanium, tellurium and polonium. GE stands for germanium. Okay. TE stands for tellurium. Okay. PO stands for polonium. Did you see all these three in metalloid? How many metalloids we have, children, in your periodic table? How many metalloids do we have? Metalloids are how many in number? Metalloids are out of 118. How many metalloids are there? The number, if you remember? Yes, very good. 7. What are all the 7 metalloids we have? The group, all the metalloid group we have, no? That staircase one, which you represent in the periodic table. Very good. What is that? The names, do you remember? All the 7. Let me write here. Boron. Okay. Silicon. Next. Germanium. Arsenic. Antimony. Tellurium. Polonium. Okay. Now, are the options missing? Present, right? Then matching with the sense? Okay. So, let's go with option B because all germanium, tellurium, polonium included in the particular group called metalloid group. So, option B is the right answer. Germanium, tellurium and polonium is the right answer. If we look into option D, what are all D options? What are D? Hydrogen gas, nitrogen gas and oxygen gas. Okay. So, correct option is option B, that is germanium, tellurium and polonium. Okay. Total we have 7 metalloids out of 118 elements. Very good. Coming next question. Question number 14. Okay. What is the atomicity of carbon in fullerene? Oh, this question is also discussed in the concept. Atomicity. What is mean by atomicity? What is mean by atomicity? Definition, did you remember, children? The word itself is atom. Okay. Yeah, very good. Number of atoms. Atomicity definition. Number of atoms present in its element is called as atomicity. Okay. So, for example, if there's O2, how many atoms are there? 2 atoms. So, what do we call 2 atoms as? Diatomic. Very good. Diatomic element. Very good. So, here atomicity means the number of atoms present in its element. For example, O2, that is having 2 particular atoms. So, it is diatomic element. Okay. So, they're asking us for carbon. Okay. Carbon in fullerene. What is fullerene? I told you the name exceptions in atomicity concept. There are some, classification of atomicity into a mono, di, and poly. You remember, children? And in the poly condition, we have triatomic, tetraatomic, and octaatomic. All these we discussed, right? So, what is this fullerene now? Did you remember fullerene? Okay, let me give you a hint. It is starting with B. Did you remember? Did you get the idea? Come on. I give the name clearly in the concept. I gave something name, a special indication I gave you to remember it carefully and clearly. Okay. So, the carbon containing, the atom with some, group of atoms is called as Buckminster fullerene. Did you remember that? Yeah, that's the bit we are going to now. Okay. In Buckminster fullerene, carbon is containing some group of atoms with a hollow, ball-like structure. That is very complex cyst-like structure we have, no? That particular concept we discussed, okay? For that reason, they gave the question here, what is atomicity of carbon in fullerene? Guess the answer. How many carbons are there in Buckminster fullerene? Simple, they didn't get the word Buckminster, they didn't give the word Buckminster, they gave the shortcut, fullerene, okay? Did you understand? So, carbon is having how many atoms in Buckminster fullerene? Come on, tell me. Very good. C60. Carbon 60 is called as Buckminster fullerene. So, what is the answer now? How many atoms? 15 atoms? No. 30 atoms? No. 45? No. What is the right option now? Yes, 60. 60 is the right option. Okay. In Buckminster fullerene, the carbon have 60 atoms grouped to form a very big hollow structures. Okay. That's the reason, and the option is 60. Option D. Okay. Coming next with the bit 15. Number 15. Okay. Which of the following statements is or are false? Okay. Fine. The nature of elements constituting a chemical compound may not retain the same. Okay. They're asking us which of the following options are false. Okay. Remember, false. Fine. Formation of a compound involves energy change. Is it? Formation of a compound involves energy change, children? Think. Option C. A chemical compound cannot be broken down into 2 or more different elements. Think. Option D. A chemical compound has fixed composition. Okay, the question here is, which of the following statements are or is or are false? Okay, remember the question is, they're confusing us, is or are, which means singular or plural, may be, may not be. Okay, think properly and do it. It should be some false statements in the given 4. Okay, first one, A. The nature of elements constituting a chemical compound may not remain the same. Is it true, children? Is the statement is true? Okay, if true, why? We discussed the nature of elements constituting a chemical compound is same, remains the same, but here they gave the word not. Hence, it is a false statement, right? Okay, false statement. They asked the false statement. I'm taking that option A. Okay, that's it. We have to go to the next question, or shall we check the other options also? Yeah, better to check because they gave the options R also. Okay, we'll go to check. Formation of a chemical compound involves energy changes. There is a change of energy in the chemical combination because there is a chemical reaction going on to form a compound. Hence, there will be definitely a chemical change going on. Okay. Next, third. Option C. A chemical compound cannot be broken down into two or more different elements. Is it true, children? No, not a way. Okay. It can be broken down. Not is not there. It can be broken down into two or more different elements. Okay. By which means? By chemical means. Very good. So, option C is also false because it gives the word cannot. Fine. Coming to option D. A chemical compound has fixed composition. It is true. All obviously true. Okay, that's the reason we are choosing the options A and C because these both are false statements. Regarding to the question, they asked us false statements. So, we are going with option A and C. Children, if you have selected one correct option, don't, go to the next question immediately. Just check the options all over through. Okay, do it have any both B and C or both A and C? Do we have that? No. Option D, sometimes they'll give all the above. You have to read all the questions carefully. If you know, for example, they gave us A, B, C, D. Okay, they gave A, B, C, D. If the option is right away in option A, if you check only option A and if you select that answer, then what about B, C, D? You have to go through all the options and then select the right options. Okay, clear? You have to first have a clear concept in your brain so that you can answer, you can eliminate the other options and you have to select the right options. Okay, good job. Moving next question. Okay, moving to next question. Here we have again, select the non-metals group from the following. Previously, we have the question which is, select the metalloids group. Now we have the question non-metals. Now tell me what are non-metals over here. Germanium, tellurium, polonium are metalloids. Okay, leave that aside. H2, N2, O2 are gases. Hydrogen gas, so nitrogen gas and oxygen gas. Leave it aside. What about Na, K, Nal? Sodium, potassium, aluminium. All these are metals, right? Sodium and potassium are, soft metals. Can cut the knife. Yeah, very good. That is the concept. Okay, here tin, barium and platinum. What are the three? Now, tin, barium and platinum. What are these three? Tell me. Tin, barium, platinum. All these three are also metals, right? These are also metals. These are also metals. These are metalloids. What is left option here? Did I confuse you? Come on. Hydrogen, nitrogen, oxygen are gases. Yes, but there are non-metals in that. Okay, hydrogen is a non-metal. Nitrogen is a non-metal. Oxygen is also a non-metal. So, that is the right option. Here we go with option D, which is, okay, these are gases, I agree, but this belongs to non-metals only, na? Okay, the name doesn't change. So, next question, moving to next question. The process of breaking down of a chemical compound into its elements, okay, by chemical means is called, okay, they're breaking a chemical combinations, okay, they're breaking a chemical compound, okay, fine, by a chemical means, fine, into elements, okay, done. So, if we break a chemical compound into some different, the particular, its elements by chemical means, which means it is telling about a chemical method, definitely should be a chemical method. So, chemical means in the sense, should be a chemical method happening over there. Okay. Now, we'll go to options one by one. Option A, cracking. Hey, what is cracking? Yes, the cracks and all. Okay, fine. B, analyzing. Analyzing is a chemical compound, chemical method. No, right? Okay. Option C, decomposition. Might be. Option D, catalysis. Okay, tell me. The process of breaking down a chemical compound into its elements by chemical method is called as breaking down. The word key is breaking down. Here, very good. In this question, the key word is breaking down. Breaking down. Breaking down of chemical compounds into its elements by chemical process is called as. You know what is that? There is a word called chemical decomposition. That is the word chemical decomposition, which means the chemical compound is being decomposed into its elements. Very good. That's the option. And here the option is decomposition. Which decomposition? Physical decomposition? No. Decomposition is always a chemical process. That is chemical decomposition. Option number C. Okay, option C. Fine. Next question. Water is a very funny, very easy question they have given in level 2. Okay, come on, let's do it. Water is a element. Come on, element. Water is an element. How many of you are saying water is an element? Water is having molecular formula H2O. Okay. So what is this now? Is it element? No, it is having some 2 different elements over here. Not at all an element. Okay, eliminate that. Is it a mixture? Mixture? No. Is it a compound now? Very good. How compound? How compound? 2 or more elements? Yeah. Mixed together, combined chemically with a certain proportion, a fixed proportion by weight. Very good. What is the ratio of this hydrogen oxygen in water molecule, children? 1:20. Did you remember? Very good. So it is a compound. Fine. Good, children. Next question. Identify which of the following is or are compounds. Again, there is a word called is or are, singular or plural. Okay. Read the question carefully before you answer, children. Okay. Fine. So is or are compounds. So first one, option A is H2SO4. Option B, AlCl3. Option C, HGS. And option D is all the above. What according to you is right option? The word here is or are. Come on. What is H2SO4 called as, children? In the class, we have discussed about the examples of a compound. You remember? What is H2SO4? H2SO4 stands for what is that? Hydrogen sulfate. What is that answer? Very good. Sulfuric acid. Sulfuric acid. Very good. And what about AlCl3? AlCl3. Option B. AlCl3 is called as aluminium chloride. Okay. And what about HGS? Option C. HGS. HG stands for mercury. And here we have right. Okay, mercury. Fine. What about S, children? Sulfur, right? We have to write the compound name, no? So now we will write the compound name mercury S, HGS as mercury 2 oxide. There is a reason for writing this particular thing, which you'll learn in your higher classes, okay? Mercury oxide. Mercury 2 oxide. Or else you can also write the name mercuric oxide. Doesn't matter. Sorry, not oxide. Sulfide, sorry. Sulfide. Okay. The other name also we can write or mercuric sulfide. Clear? So all these three having some, the proportions, the fixed proportions by weight and also the ratio matters. So accordingly, if we see all these three belongs to compound thing, okay? Because H2SO4, AlCl3 and HGS, all these three belongs to what? Compounds. And we can choose the option D, all the above. Okay, clear? H2SO4, sulfuric acid, AlCl3, aluminium chloride, HGS, mercuric sulfide. All these are compounds. Very good. Going to next question.